That starts the recording. And now I'm going to stop sharing. And Hayden, you should be able to take over.
All right. Let's see.
And let me see if, let me get the sound to go through this better speaker. All right. I think you should be good and loud now.
Okay. Can everyone hear me?
Yeah. Yeah, we can hear you.
All right. And then I can, let's
we
see.
can see you, and you can share your, if you hit the green share button, you can share your screen.
Let's see.
I can see it from here. Here we are. Yeah.
All right. Here we are.
Good.
So can I ask how many people are in attendance?
We have about 5 or 6 in the room and some number online, which I can't see, but I think you can see.
Oh, okay. Oh, just curious.
Yeah.
So my name is Hayden Barnes. I am a accidental startup founder. I have been tinkering with Linux since the late 90s. Back when, if you wanted it to work, you had to build your own kernel from scratch. I mean, it was just required. For many years, I worked like you on Mac OS. I enjoyed the Unix terminal, but having access to, decent desktop apps, Office and those kind of things. And I had dabbled in desktop Linux for a long time and always found it came up wanting. So after Apple, the keyboard fiasco with MacBook Pros, I decided to listen to some friends and try out a ThinkPad. And I absolutely loved it. And I put Windows on it, and I tried Windows 10, and it wasn't that bad. It took some getting used to coming from Mac OS 10. This is not an advertisement for Windows 10. Don't worry about that. But I missed the Unix/Linux terminal, and I found it with Windows Subsystem for Linux. And Windows Subsystem for Linux, WSL for short, is a translation layer that allows users to run Linux binaries natively on Windows. And it doesn't do this in a virtual machine, and it doesn't do this by emulation. It does this by translating the Linux system calls directly into Windows NT kernel system calls. Because both Windows NT and Linux share the x86 background, the system calls aren't that different. They use a common memory structure, unlike BSD. So translating the system calls is actually not that difficult. A lot of those system calls can be translated directly. Some need a translation layer, some need to be just completely implemented, on top of the NT kernel. But what it gives you at its core is access to Linux tools. And I can show a few of those now. The story how I became an accidental startup founder is that multiple distributions are available for Windows Subsystem for Linux, just like you go to DistroWatch and there's hundreds of Linux distros. You can get Ubuntu, Debian, SUSE, Kali Linux from the Microsoft Store and install them. And myself and a handful of WSL enthusiasts, we were heavily modding WSL and kind of doing things to it that weren't really intended and weren't supported by the upstream Linux distributions. And we decided that we needed, in classic open source Linux tradition, to fork and develop our own distribution just for WSL. And it was originally called WLinux. It could be built entirely on WSL, code and all. We prioritize WSL related issues, and then we bake in dozens and dozens of optimizations that we have worked on to create what we now call Pengwin with a W. So I'm going to show a couple slides here from an upcoming presentation we're having at Microsoft Build.
Can we make those bigger? They're only using about half your screen. There's like a bar.
There we go.
But it's now there's some video stuff on the right covering up some of the slides. Might be able to minimize that or something.
Is that better?
Well, the right half of the slide, the right 1/4 of the slide is covered by a video and some blank videos of other people.
There we go.
There's a bar of video. That did not do anything. The bar of videos is still there. Wait, maybe it's mine.
You can try to move the video.
Wait, it's mine. I figured it out. Okay, never mind. It's my machine. I thought it was yours. Never mind. Go ahead.
All right. So a little bit about our distro. We are a worldwide team. We've got Patrick Wu. He's a grad computer science student in Hong Kong. We've got Carlos. He is a 20+ senior year Java developer. If you vote, in an election outside the United States, you probably use election software that he wrote and contributed to. And then we have a kernel and InfoSec specialist who helps us from the UK. And we build in tools that make it easy to get started on Pengwin. Now, this isn't an ad for Pengwin either. I'm not trying to sell anyone anything. But just wanted to kind of give you that background and, show you some of the things we can do. Let's go to, let me show you some things to do. Okay, so first, enabling WSL if you haven't already. If you're watching this, you probably shouldn't because it requires a restart. But it's done in apps and features. Hang on, I think the, there we go. There we go. And then, of course, you have to get down into some of the classic Windows. And then you enable it here, Windows Subsystem for Linux. You click OK, restart. You can also issue a PowerShell command that does it pretty well. You can find that in the documentation and on our website, pengwin.dev. So let me show you some of the cool things you can do. I mean, that's what you came here to see. Is what is it? All right. So this is Pengwin. We've launched Pengwin and we're in a bash shell. Okay. So first thing you'll notice, there's no init system. There's nothing starting services. We are starting some things in the background, but that's things we've modded. By default, nothing is started in the background. We do add in things like bash completion and the ability to launch an SSH server or those kinds of things optionally. But at launch, here you are at a bash shell, and we're Debian based, so we use apt to install things, just like you would on any other machine, Linux machine. All right, so what's special about this? Well, it's running natively. We didn't have to spin up a virtual machine. We didn't have to, if the internet goes down, we don't lose connection to our VPS. If you have, good hardware, it's gonna be fast. And you have access to the entire universe of Debian packages. Now, there's also, like I mentioned, there's other distros. There's Fedora, there's OpenSUSE, so you can access those as well. But we chose Debian to base Pengwin on because of the wide breadth of packages, and just because so many maintainers maintain an apt repo or a Debian file, at least if not for Debian, for Ubuntu, which is cross-compatible. So while that's unpacking, we're going to open another one. And so what else can we do here? Let's go to our, how do we, escape this Linux environment? We've got a classic Linux environment, but we can also go to our Windows environment. And we access that. Our C drive is automatically mounted, and would give us the opportunity to go, into our files. Let's see. Actually, I want to go to my desktop.
Pardon me. Can you make the font bigger? It's pretty hard to see.
The font. Let's see what I can do about that.
Ah, that's better.
We'll make it even bigger. How about that?
That's much better. Thank you.
Okay.
Yeah.
So I'm actually here at Mount C, and then I traverse my C drive, just like you would in command line. And let's see, I downloaded a folder here. This is a Git folder. Just going to do git pull, make sure we're up to speed. All right, we're up to speed. Let's go. So in this folder, I have a little hello world, and we can check that out with, open that with nano. All right, hello CCFC. And we would build that, of course, for Linux with GCC. All right. And we have hello world. Easy enough. And we did this on Windows. There's no Linux kernel running. But let's do something different. Let's, at the same time, build it for Windows. Ah, missing a package. Make sure we've got that installed. Make sure we've got Build Essential too. Oh, we probably need to wait for this one to finish. So what I'm trying to demonstrate is, it is your traditional Linux environment. And what we're starting to see is kind of a blurring of the lines between platforms. Linux and all of its tools and tool chains is more and more becoming kind of a runtime, within containers, on our desktop, with serverless type deployments. And the idea of needing to run desktop Linux, well, a good use case for some developers, more and more people are not interacting with Linux at running in front of them. They're interacting with it in the cloud, and often in a very abstracted way in containers. Sometimes even more abstracted than that when it comes to services. All right, so all right, so another thing we can do before we get back to our hello world is we have an X server running. So we can run GUI apps just like you would on Linux. And you get some glib stuff running in the background. You can minimize that. But here you are on your desktop. And home. And you have instant access to, so you can run these tools right, next to each other at the same time. So if you really wanted to, code Vala, for example, which is native to GNOME Builder, but don't want to have to dual boot Fedora, you can just run GNOME Builder and code in Vala right here on Windows. All right, let's try this again over here. All right, and then while that's running, so we don't all sit around and watch it install. Let's see. What's going to show you? Let's see. To give you an idea of some of the tools that people have requested in Penguin and are using in Penguin and on WSL generally, this is the Penguin setup tool. Like other distros, we pull from Debian package repositories, but we also maintain our own app repo with our custom packages and host those in a continuous integration, continuous deployment system that we wrote on pretty off-the-shelf hardware. Nothing too groundbreaking. It's just the idea of putting it all together for this platform. But as you can see, people request a lot of editors. NeoVim is popular, Emacs, Code. It's possible to run code on Windows and link it directly to Penguin. For example, I have that example here. I have Visual Studio Code, and you can, debug directly inside Linux while writing your code on Windows. But a lot of people want to run code directly from the Linux side, so we make that available. In terms of programming, we've got C++, .NET, Go, Java, a lot of Node, a lot of Python. We're seeing pick up, a lot of users who are coming to Linux for the first time. They used to have to, learn what, they might have come to programming through front-end programming, and now they want to learn more about server-side, activities and Linux. But, the idea that learning Linux requires you to learn how to dual boot and write your own grub configuration files. That's one way. But another way is for them to come on board this way and interact with Linux here. And so we're seeing a lot of front-end developers kind of take their first steps into Linux using WSL. Some other interesting things we can do. We've got different people, Bash is not your only shell. You got ZSH, CSH. You can install KSH. Fish is very popular. We have one of the modifications that we built into Penguin is non-Latin keyboard support, GUI keyboard support. And that's because WSL is very popular in Japan. About half of our users are in Japan. So we build those services in for them. Let's see. We're adding Homebrew, which you may recognize from Mac OS. We do Ansible, and we support several cloud services. That's because people are building their Node apps, here on WSL, and then containerizing them and deploying them directly to public clouds. This is just what we see folks doing. All right, let's go back here. Let's build debugging Linux. Are there any questions at this point? I'm going to continue, but has anything popped up so far with anyone that they'd like to ask, or specifically see?
So why is Penguin better than Cygwin?
So Cygwin is a great tool, and this is certainly in the same category. Kind of on a spectrum with containers and virtual machines and Hyper-V. Pengwin tools have to be rebuilt and recompiled from scratch. And with WSL generally, you're getting the latest Linux packages and tools. So, I mean, some of the binaries in Pengwin are quite old. And, you know, for some use cases, Pengwin may make more sense. But, you know, with WSL, you have access to, you know, your choice of package installers, not just the one Pengwin installer, from all the different distributions and all their various nuances. In terms of speed, WSL is pretty fast. The main bottleneck with WSL is I/O performance, and that's because Windows Defender is actually scanning actively your Linux files. In fact, Windows Defender will detect compromised node modules, you know, that have code that's been inserted to mine for Bitcoin and that kind of thing. Windows Defender will pick up on those in the Linux environment. So that is a small performance overhead that the team is working on. But in terms of head-to-head on high demand CPU performance, not GPU because accelerated GPUs aren't supported, but pure CPU performance, it meets or exceeds bare metal Linux. All right, let's give this another shot. Okay, so there we go. So now let's open command, right? All right, we do hello world.exe. There we go. So we've used the same code to build for both platforms, except for that one package dependency, you know, right back and, you know, back to back. So another tool that we're seeing is not just cross-platform development. This is a very simple version, but in addition to cross-platform development, we're seeing system administration. So one of the things that we see are sysadmins using it to deploy Ansible playbooks. And I have one set up. I have the remote Windows established. And we're going to wait for it to connect.
You know, I got a question about device. Okay. I'm confused about device drivers. Are you using Windows device drivers or Linux device drivers?
So in terms of device support, there is support for file systems. So FAT32, NTFS, exFAT, that's supported on internal disks and can then be mounted from external media. There's very limited external hardware support beyond that. Basically, serial communication and some custom USB type work. If you want to reach outside hardware, you pretty much have to pipe it through to a some sort of proxy on the Windows side and then go out that way. So there is no Linux kernel, therefore there is no kernel modules running that would provide any sort of hardware support.
There's no Linux kernel. So when you compile a GCC, it's trying to call glibc. What is it doing? Probably having a shell to the Windows API or what?
So it is on the fly translating the lower level system calls from glib into NT system calls.
Wow.
So it's even so for example, like the Wine project. The Wine project implements the Windows API on Linux or Mac OS. This goes even lower than that. This is not implementing any sort of Linux API. It's implementing the core syscalls, and they cover about 95% of Linux syscalls. There's a few standouts that sometimes just aren't supported well. So there's things like IP tables, low-level networking stuff just isn't going to work because it just doesn't.
Yeah. Okay.
Yeah.
Thank you.
Low-level networking isn't going to work. Sound isn't going to work. Although, just like when we used an external X server, you can build Pulse Audio for Windows and then pipe it from Linux to Windows, and you have audio. So, that's an option as well. Let me see what's going on with let me try that again. Why my remote Windows isn't coming up. If not, that's okay. I've got a backup test I can show you with a remote Linux. So we could write an Ansible playbook. Let's get out of Windows and go back to Bash. There we go. All right. So this is a pretty simple Ansible playbook. Ansible is a way to standardize deployments. And we can create an application and run a script, and it deploys automatically and maintains installs all of our dependencies and runs. And the great thing is that you can run this on Linux, and you can run it against Windows and Linux. So you can configure your Linux and your Windows devices using the same technology running Linux on Windows. So the blur between these platforms, especially in hybrid environments where you have end users running Windows and backend servers running Linux, and your DevOps team needing to do both, this is where it comes in handy. So what this Ansible, I don't have an app ready to deploy, but what this Ansible playbook does is it actually takes a simple Docker container, installs Docker on our remote Linux machine, installs Ansible in Azure, and then it deploys a Docker container from our private container registry to a local Linux server. So this is just an example of kind of the way this can help glue these more and more complicated and new leveled ecosystems we're in.
I've got a question about security.
Okay.
People say that virtual machines are more secure than containers. If you're running a web app in Pengwin and somebody gets root on it, can they get administrator on the Windows system underneath it, or is there some barrier there?
That's pretty bad. So the thing is that privilege escalation inside the Linux environment won't lead to privilege escalation inside Windows. So gaining root inside WSL doesn't give you administrative access to Windows. It will give you free range to all of those users' files. So it is still a security risk, running, if you establish an SSHD on Pengwin or WSL, you want to disable remote root login, and ideally use keys instead of passwords. And just practice the same basic Linux security steps you would on a bare metal Linux container. but yeah, I mean, it's not great. I mean, you see the access that I have to my entire system here. So, you know, and when we have to go through a special vetting process to have our app on the App Store because we have such high level access to the system. Yeah, it is a security risk, and there are CVEs that get filed against WSL from time to time. But you know, one of the advantages of having Windows Defender there is that it has caught, it heuristically catches Bash that is obviously trying to, you know, infect your system and scoop up data. So it's a, you know, it's a new vector, but there's also plenty of mitigation there. So let me see what other things I can show you. So let's see. Let's do, I've got Pengwin installed already. Let's open terminal code. All right, let's make sure pip is installed, upgraded. Oop. So, I mean, but speaking of deploying web apps, I mean, that's pretty straightforward. And that's what we're seeing a lot of people use it for, is who are first getting started with Linux and moving in. I thought I just did. Okay. All right, so we've got Flask. We can go. All right, so we've got a demo running with Flask. We can open, and there are you can use Window Manager, and you can use Tmux and Screen, and your favorite app manager. I'm just a messy guy who just opens new consoles all the time. I know like running i3 and all of those keyboard-driven window managers are all the rage, but I'm just lame. Okay.
Oh.
Well, no, actually, that's a bug. That's something we're going to look at. I'm running on a pre-release version of Pengwin. This is the upcoming release. So this point WSL view doesn't work because that should open my default browser with that. So you know, here we go. Flask is just a simple Python web app framework to throw something together, and there we are. So you know, it's not just frameworks. You can run Apache if you want. You can run SQL. You can run a whole LAMP, you know, Nginx, whatever else you're looking for. So yeah. What else?
But no firewall.
Well, no, other than the Windows firewall.
Yeah.
But it works with the Windows firewall to open those ports unless you have them locked down. So one of the things we do, we offer Pengwin Enterprise, which is a custom deployment of Pengwin that we're seeing pick up in finance, in government research. Basically, the sysadmins are used to locking down Windows and using Windows in those hyper secure environments, often air gapped. But then they want to use WSL. So what we do is we actually create a custom version of WSL based on CentOS. Usually, we also support RHEL and Scientific Linux. But industry is starting to take notice of WSL, especially devs deep in these enterprise companies who are like, finally, we can use these tools on the Windows machines our company makes us use. So let's see. And, you know, there's good old fashioned classics like, you know, install Synaptic and get a GUI package manager. You know, anyone who is still interested in exploring Gopher space can install a you know, GUI Gopher client. I mean, you basically have this, you unlock this whole world of open source and free software that you used to have to dual boot for, right next to Office and you know, your other Windows apps. So let me go back to just show you a little bit more of the presentation we're doing at Build. It's a little more focused on Microsoft technologies because it's Microsoft engineers, but you can connect Visual Studio directly to WSL via SSH and actively debug .NET and C++ applications running on Linux from Visual Studio. So if you love Visual Studio but want to write for Linux, you can. Those are some of the things I showed you. You can make Pengwin the default terminal in Visual Studio Code, program right in there, use a plugin, delint, deploy all from within your text editor. We have a secure bridge to Docker. So Docker does not run correctly inside WSL yet. It will soon. But for now, what we have is a kind of what I mentioned before, where if you need to reach outside the WSL environment, you have to build a pipe. So we have a pipe that's written in Rust that, actually take that back, it's written in Go, and it pipes the Docker calls through a helper app to Docker on Windows, so that when you install Docker on WSL, you are using Docker on Windows, but you're using it as if, I mean, you wouldn't know the difference from the bash, from the terminal. So if you want to see this in action, please tune in to the Microsoft Build Talk next Monday. We're doing from Seattle. Again, because it's Microsoft, we're going to show them deploying that Docker container directly to Azure. We're going to show how to then deploy that via Ansible to a remote Linux server. And then we're going to show using Ansible on Linux, running on Windows, to install Linux on Windows. Because why not? Just to show, you know, to give this folks an example of not only of the cross-compatibility and cross-platform nature of this, but the ability to administer machines on a cross-platform. So let's go see. Let's see. So if anyone has ever used Debian, or, you know, before the fancy stores they have now in GNOME and KDE, and you use Synaptic, you know, you have everything, you have access to everything here that you would pull over from Linux. So we're not competing with desktop Linux, and that's what a lot of people are concerned about. We're actually introducing people to Linux. I think a few people who might consider dual booting probably won't now, but we're also seeing a lot of people come over from Mac OS and actually engage more in Linux via WSL and the wider open source community than they were before. And that's what we're keen about. So like our support system requires you to open an issue in GitHub. So we are serving not only as an on-ramp to Linux, but to the wider open source community. And we collaborate with other open source projects. For example, when there's incompatibilities that come down the line, or some of the tools we use to build our images, we detect bugs and push those bug patches upstream. And we have I know users who use WSL to code on the Linux kernel, and then build it and push it to test hardware. So all of that is out there and available. It's just something new and exciting, a new way to use different computers together. Any questions? No?
You mentioned Gopher. Can you show us that?
Yeah, that's what I'm installing now. Forg is a really great GUI Gopher client that's still actively maintained and written in Python. So we're getting that now. But yeah, Gopher's there. I mean, and it's so handy. And I see a YouTube video that I want to save. I use YouTube DL to save it. A big file I want to download, I just copy and paste the URL into ARIA2, and it's just a built-in there we go. Download manager. Here. Oops. There we go.
Here's Gopher.
Yep. Let's see. And we've got Gopher. So, there's a lot of cool things you can find and do here, But there it is, Gopher on Windows 10. Anything else y'all want to see?
Yeah, good.
Can you run GDB on a Windows executable?
I'm sorry?
Can you run GDB from the Windows subsystem for Linux on a Windows executable?
That's a really good question. I haven't tried it. I'll have to do some research and get back to you on that. That would be very useful, though. But in terms of like debugging Linux issues, we use strace, and and if that doesn't turn up the issue, we switch to the Windows side and use procmon to debug. So, but GDB, that would be interested to look into. So I don't recommend it for gaming. There's no accelerated graphics, although that is the most highest rated feature request. and on the user voice, which is funny because you can now run so many games on Linux just fine, but people want to be able to run games on Linux on Windows. But you can run QEMU. You can't run KVM because that hooks into the kernel, but you can do a lot of emulation with QEMU. And scripting. So if you want to check out the walkthrough that I kind of plucked some things from today, that's at penguin.dev/build 2019, and that is the landing page for our talk that we are having at Build. The slide deck is here. There's a walkthrough. There's code samples. There's links to our blog. I've got some benchmarks there. All the links for the team are here, and some other resources, some folks who support and contribute to our work. So we are actually official partners with both Microsoft and Red Hat, which is a very strange place to be. But we're there. We sponsor DebConf, and we know in the Linux community people are very skeptical of us, and we know in the Windows community they're like, well, we have PowerShell, why would we need Bash? And then I show them Bash, and that they can run PowerShell in Bash if they want, and get the best of both worlds. So we publish Penguin Enterprise. There's no official Fedora for WSL, but Fedora has what's called a remix program, and we participate in that to make a remix of Fedora available for WSL. So, we've got 29 running. We're testing 30 right now. We don't expect any major issues. WSL Utilities is one of our upstream projects that we host. This is a set of utilities for WSL that is maintained by one of our contributors. We actually host packages of this for every major WSL distro. Including, you can even get Arch and Alpine. So you can find more distros by searching the Microsoft Store for Linux, if you can imagine you'd ever see that day. Mm-hmm. So you got SUSE, Debian, Ubuntu, Kali, OpenSUSE, and there we are.
But almost nothing in Kali would work without access.
You're right. There are a lot of low-level tools in Kali in WSL that don't work. Yeah. But there's a lot of remote vulnerability tools that do sometimes. Depends on what you're scanning for. But you're right. It is pretty limited. But if you're doing an initial pass, Kali on WSL does a fairly decent job. And it's officially supported by the Kali team. So, I mean, that's not just an unofficial spin.
Well, it's very interesting.
Yeah.
A strange new world, an alternative to containers and VMs.
Yeah, yeah. And for interacting with those, you can use, you can run commands on your Docker container, from WSL. You can even run commands on your hypervisor, a Hyper-V container, from Bash on WSL. So we're getting to this place where, operating systems are becoming runtimes, and Linux is becoming a runtime, and Windows is becoming a runtime, and you even see it in the structure of the operating systems as Windows core becomes closer and closer, and the shell gets disintermediated from the core Windows experience that now runs on tablets, Xbox, servers, maybe one day again mobile. And while at the same time Linux does too, and now concurrently.
Mm-hmm.
So I hope this was interesting. I hope got to show some folks some interesting new things. I urge you to check out the slide deck, the walkthroughs, the code samples. They're all on GitHub. All of our source is available on GitHub. Everything we do, from how we build our images. Let me see if I can. There we go. Everything we do, from how we build our images to our CI/CD system and our packages, is all available online. So you're welcome to take a look. I invite you to. You can build from source on your own, and of course we very, very much welcome pull requests, helpful issues, and that kind of thing. So you can check out pretty much everything we do here. Yep.
All right. Well,
Okay.
any more questions out there? Doesn't look like it. All right. Well, thank you very much. Please, which one?
How about CPU usage? You can assign, like if you have a quad core, you can assign 2 processors for this program, right?
I'm sorry, what was the question?
He's saying you can't assign which core
Like
goes to
you have
Linux.
a quad core, so you have 4 cores. So can you assign 2 cores to your process under the task manager or whatever?
Oh yeah, do they show up as their yes. So let's see.
All those processes.
Let's see. There we go. So here, so yeah, you can find those processes and let's see. Interact with them as you need to. So I'm actually not familiar with them. I've never actually assigned a process to a specific core, but they are, you can view them in Task Manager. How do you normally do that?
I thought maybe some software had the ability where you can give this 2 cores to this process.
I haven't seen that.
Maybe that's something you can come up with then.
Oh yeah, right.
Well, that's virtual machines.
Yeah, that's kind of one of the limitations of where we are, is in the space we're doing, is that we're stuck between two big corporate giant, a set of corporate giants. We rely on Microsoft quite a bit, and we have a great relationship with them. But we also rely on the Debian community and Red Hat and Oracle, and moving those institutions to do things to help this niche has been quite the challenge. We've had some great successes. We've had some failures. One of our successes was we actually worked with the Berkeley DB team at Oracle to debug an issue in the Berkeley DB implementation inside of RPM that was affecting some of our Penguin Enterprise customers when they were rebuilding their RPM databases. And it turned out to be a misbehavior by the mmap function call. Basically, Microsoft had accidentally flipped the mmap function call so that when it went to rewrite the memory, it was writing it from the beginning of the file and not the end of the file, and it was causing RPM to just segfault in most cases, but just give up. So, but we had to figure that out and then document it and then take it from one company to the other company. And the good news is we've got such a great relationship now that we were able to get that fixed in Windows within days. So it's this weird world where we have upstream patches and bug reports going into both the Linux world and Windows. It's weird. So, but it's fun. And, you know, we wanted a WSL distribution for ourselves, and we made a distribution for ourselves, and we have been able to, you know, build a sustainable revenue stream, you know, for 4 part-time devs. And we're expanding and we're picking up notoriety, and, you know, we'll see where it goes from here. But, you know, I encourage people with, you know, interests like this to find these niche areas and go create open source projects in them and be willing to charge for them and build companies on them. Because it's, you know, no one was going to do this. No one was going to do this for the community. And so we just kind of stepped up and did it. And, you know, it's been a wild ride. It's been quite the wild ride. I never expected, as a former Mac OS developer, you know, who spent so much time on Linux, to be speaking at Microsoft Build next week. But here we are. Mm-hmm. And then we're going to hear the keynote from Satya Nadella, and then he's going to get on a plane and fly and do the keynote at Red Hat Summit in Boston. So within a day of each other. So here we are.
Mm-hmm. Good.
All right.
Well, thank you very much.
You're welcome. Anyone from City College of San Francisco who emails me from their student email address, I will send for people who attended, I will send a promo code for a free version of Penguin. Okay. So,
all right. Thank you.
Yep. And that's just, that's Hayden. You can go to penguin.gov, not penguin.gov, I'm thinking, just contact@whitewaterfoundry.com and send me an email and just say, hey, I was there, and I will shoot you back a promo code.
Okay.
Check out our website, check out our blog. If you have any constructive feedback, if you want to get involved, so we have a revenue stream. If you get involved, you will get paid. Most of the income goes out to developers in the form of grants or scholarships for maintaining specific parts of the code. So we're very open like that. On the other hand, if you just want to do a drive-by commit, that's fine too. But we welcome all those levels of involvement. So, but please follow us on Twitter, follow us on the blog, just see what we're up to. So I think what we're doing is cool and different. And I hope other people at least find it interesting.
Mm-hmm. Yeah, it's interesting, all right.
So how long was this development?
How long has this been in development?
Yeah.
About 8 months.
That's how it began?
Yeah, so I got it from idea to on the store. It took about 6 weeks. And mostly that was getting clearance from making sure we were in compliance with GPL and Microsoft Legal and Debian, making sure everything was clear. So we weren't infringing anyone's trademarks or anything like that. Very, very rough. But we've been continuously adding features every week. We moved from a text-based installer to a GUI installer, and then we moved our GUI installer from, we then refactored it and compartmentalized it and made it more extensible and deployed it with our new CI and CD system. So we had to move everyone from a system of upgrading from scripts off GitHub to the app repos. So we've gotten very, very good at basically managing tens of thousands of people's Linux installs all at the same time. It's been quite the challenge, but the transitions, each one has gone pretty well with enough planning and testing, and it's been a wild 8 months, but we've done most of this in 8-9 months. So, and as more people join the team and bring on specific skills, we can then flesh out more of that, more of those areas. So like, a Java developer joins and he helps build out the Java tool chains and make the Java tool chains work together really well and give us what a modern Java developer wants. So it's a cycle.
Are you going to put Linux in a box, make your own form of Linux in a box?
Is that, what do you mean?
Well, they have those little boxes for Linux or like Raspberries, I think, or
yeah.
You're going to have your own form of a Linux in a box. That's the thing.
Yeah. And, you're welcome to, the great thing about Pengwin is we're on GitHub, so you can always fork us and make your own WSL distro. That's an option too. But yeah, and a lot of people use WSL to program their Raspberry Pis and that kind of thing. You can cross compile binaries for your Raspberry Pi on WSL, and WSL Pengwin and Fedora Remix are available for both Windows on ARM and Windows on x86. So you can actually use the same Linux binaries on Pengwin on ARM that you would then install on a Raspberry Pi. They're the exact same binaries.
Have you thought of making a router compatibility so you can make some sort of Linux system that will run on many routers, because there's DWRT and OpenWRT? Have you sort of thought anything about following that path?
No, that doesn't really pique my interest personally. Just to be honest, that's kind of a low level thing. If I was going to probably design a router, I'd probably start with the BSD, to be honest. Linux is great, but something like hardened BSD would, I think, be really high performant. So we'll see where RISC-V goes, and I think we'll see a whole new generation, hopefully, of better routers, because it's been 15 years and they still suck.
There are some routers with processors on them that are more expensive.
Yeah.
A bunch of them that have like low-end processors to make the router better.
Yeah, and I'm familiar with flashing the Linksys routers with the DDWRT and that kind of thing. That's just, you know, I've always been an operating system nerd. You know, I started Linux. I spent a lot of time on BOS. You know, I was on Mac OS for a long time because of the Unix and using the Unix system. And, you know, the project I had before Pengwin was actually a build of Minix for Windows before Windows Subsystem for Linux came along. So I'm just a systems guy, and you know, I just share it by making the best one I can for other users.
Have you taken a look at Windows before? You know, that product came out and then that sort of went flat.
Windows? Yeah, Windows. I paid for Windows. I had like a disk from Windows. Very much so. Yeah, I mean, see, you know, people get upset when they realize Pengwin is $10 because people don't like the idea of buying Linux. But back in my day, you used to buy Linux at Best Buy in a box for $50, $60. You know, and since that doesn't happen anymore, Linux is most on the desktop for end users is mostly volunteer now. And if it doesn't fit what Red Hat wants for the enterprise, it doesn't get a priority. So, I mean, enterprise loves systemd, and a lot of end users don't like systemd, but guess what wins out? Enterprise, because folks are willing to pay for, the folks who are willing to pay for Linux desktops are the enterprise. So that $10 we ask for is our social contract between us and our users, that we put them first, you know, and then when businesses want what businesses want, they can come to us for Pengwin Enterprise, and that's a different relationship. But we ask for buy-in, and, you know, I think we've shown that we've been really good stewards of the contribution that people make to buy Pengwin. We provide a lot of support. I mean, I have folks who join who get Pengwin and email us and say, how do I use Bash? And we'll help them learn Bash. That's fine. You know, we'll tutor them through the basics of Bash to get them started. So it's just an opportunity for us to make something interesting, introduce people to Linux, kind of open up the world of Linux. And you know, people take it from there. People use it to program their routers. People use it to program cloud devices. And, you know, every once in a while you get someone who says, I want my desktop to run on this, and they switch to desktop Linux, and that's great too.
All right. Well, I think that's it. Thank you.
Okay. No problem. Again, don't forget to email me if you came and you want a free license. You can also request a sticker from our website if you're interested. But please check us out on GitHub and file those bug reports and pull requests. We really appreciate those. And if anyone wants to get more involved, you can reach me as well, and we will scale up your involvement to your level of comfort and your level of interest. And we will find a way to make that work in the team.
Okay.
Okay.
All right.
All right. Well, thank you for having me. I really appreciate it. I appreciate this opportunity.
Okay. I'll send you the link to the YouTube video.
Great. Thanks.
Okay. Farewell.
All right. Bye-bye.
Yeah, that's okay.